Ik ga de inleiding in het Engels doen, omdat de sprekers ook hun lezing in het Engels gaan geven. To finish off our lecture series in cooperation with Beaux-Arts, the public team opted for the theme of water. Water is one of the most important elements that dominated urban design throughout its complete history. Where waterways crossed, urban settlements appeared. However, due to the impact of industrialization, 2 centuries ago, water was gradually disappeared from people's view and people's mind, being reduced to a commodity and considered as a technical device. Luckily, today, the revaluation of water is at stake, motivated by ecological concerns and by new challenges, such as climate change. One of the researchers of OSA on this topic is water in urbanized landscapes in Flanders. This research is not only focusing on the ambiental revaluation of water in the city and in open space, but mostly looks at opportunities as well as implications for the urban structure. The research is conducted as a research by design. As an interdisciplinary platform, it tries to bridge the gaps between urbanists and hydraulic engineers. The researchers of tonight, who are going to put light on their work, both studied architecture and urbanism internationally and nationally. May we therefore present to you tonight Isabelle Putseys and Christian Nolf.
Good evening, thank you for inviting us. Thank you, public, for inviting us. So, as it was said, we were invited to present an overview of our research, which actually started a few months ago, so not so long ago. So Isabelle and I, we are working in OSA, the research group, Architecture and Urbanism in the KU Leuven, and we're both busy with a PhD with the title Water in Urbanized Landscapes, and the subtitle is Integrating Civil Engineering and Urban Design Approaches in Regional Landscape Development Projects. One of the particularities of the research is that the promoters are from urban design field, like Bruno de Middel and Kelly Shannon, but there's also a promoter from the hydraulics department in Leuven. So the idea is really to work together as much as possible. So this evening we're going to show you where we stand with our research. First, defining what we mean about water urbanism, then see which are the challenges we are confronted to today in terms of urban and water. Show our 2 case studies, because this is a research by design, so we are both working on 1 case study and illustrate it with a number of references, and then make a conclusion. So, water urbanism could be defined as understanding how and to what extent water logics and urban development have been and are mutually determining. It means to what extent water determined the way the city developed, and reversely how urban affected the water structure. So there are some international cases we just saw, but we are focusing on Flanders. So what does it mean? What does water urbanism mean in Flanders? The first map looks at the Flanders, but from the hydrological point of view. And the first striking thing we notice is that all important cities are located along or on a river. They all belong to the Schelde Stroomgebied, so the Schelde catchment. So this is like a large view, but when we go more into details, we see a number of different relationship between city and water. So I will not go into details, but just show a few views of of places where water and urban or cities are related. So in Antwerp, everybody knows it, it's the way the city used water for economy and also, but also for defense with different defensive line. Ghent also is really located on the network at the crossroad of different rivers with a system of canals, which is now still, so at the right side you see it, but it used to be much more complex not so long ago. So these two cases were very explicit. Everybody knows that Antwerp is along water. And then there are some other cases more implicit where a water structure determined urbanism. In this case, it's in the north of Hasselt, where former peat, so veen in the Netherlands, exploitation were reconverted into fish farming ponds, and then an economy was based on that, and then settlements developed. And another more generic example is how the agricultural logic, so how to irrigate, how to drain, has determined urbanism that came later. This is in the Leyenstreek. So the question is, why is this water urbanism a hot topic today? It's been more or less forgotten for the past 2 centuries. Water was not considered in any urban theory, but now it's really becoming a hot topic. And this because there are many challenges we are confronted with. The first one is related to climate change, which will lead to the rise of the sea level. So when we talk about sea level rise, we all have in mind the coast that might be affected, but actually in Flanders it's also the whole estuary of the Schelde. So this map in blue shows everything that is below 0 and 1.3 meters height. So according to some scenarios, that would be underwater within a certain future. Another consequence of climate change is that the rainfall regime will be changed in Flanders, or it will change everywhere, but in Flanders it will lead to drier summers, wetter winters, and more intense extremes. It means that there will be more intense rainfalls in shorter periods of time. So next to these natural factors, there's also the question of urbanization that is ongoing, and that leads to less infiltration and more runoff. It means that water can simply not infiltrate and goes more rapidly into the river. So this scheme is a kind of classic scheme in hydraulic science. So the curve on the bottom is the normal reaction of a river in case of rain, and the one much more condensed is the reaction of a river if the environment is completely paved. It means that you have a peak flow, all water goes very rapidly into the river, and this is exactly what needs to be avoided and to be prevented. And this topic of ongoing urbanization is also quite a hot topic, because so Flanders is already now one of the most densely urbanized areas in the world, and for the next 15 years it will further increase. So in red you see how these are predictions where and how it will increase further. Another factor is that the river system has been completely manipulated through time, and actually the capacity of the river system is completely reduced to a kind of minimum. This shows the winter bed of the Schelde estuary, so the maximum capacity between dikes of the Schelde in comparison to the wetland at the time of Ferraris. So you see there, very in a simple way, how the river has been, the space for the water has been restricted. And this was a long run process of the idea of controlling water, making it go away as fast as possible. When you read all text about this type of interventions they made, the idea was really, in case of storm, let's get rid of water as fast as possible. So rivers have been straightened, canalized, all meanders were cut off. This has been the logic for centuries and is now being a bit reconsidered. So the result of all these factors are leading to what you see here. So a number of disasters which are happening more and more often, and also what is specific is that it's new disasters and that they are happening in unexpected places. So the water system appears more and more like very complex machinery that nobody really controls anymore. So in reaction to this, there was a big effort to develop a new water management policy, and it could be considered as a small revolution. So in 2000, there was the European Water Framework Directive that is valid for whole Europe, and it was translated or applied for Flanders into the Integral Waterbeleid. And the two, so they're proposing lots of things, lots of new way to deal with water. But let's say that the two most important progresses is that first it takes as unit of management of water no longer the administrative boundary of the municipality or a region, but really takes the physical boundary of the river system as the unit for water management. So it means that for Flanders, you have actually three scales of plans, or three plans, one international scale, one. Then for Flanders, you have for each main river one basin, one plan, and then within each of these basins, a sub-basin plan. So it's the same principle, for those who know it, as the structure plan, which has this regional, provincial, and municipal scaling. So it's the same idea of the main guidelines at a big scale, and they get refined according to the specificities of the local places. So that was one major progress, and the other one is the shift from an end of pipe approach, where in the past we used to solve water problems in a very defensive way, like we protect this place, but we don't care about what happens downstream. So it is a totally new approach that now is much more preventive, saying let's keep water as much as possible where it is now. So they defined and they are promoting what they call the three-step strategy. You can see here at the bottom. And it's the idea that you should at first make as much as possible efforts to reuse, to let water infiltrate and retain it. And only once this is totally exploited, you can skip to the second strategy, which is storing excessive water. So once the water is in the river, to make sure it doesn't overflow, you can either make retention basins along the river or create some floodplains along the river. And this is what they're actually doing now for the Sigma plan along the Schelde. They are recreating controlled floodplains, so kinds of pockets you see there with a new dike that can get flooded in case of high waters, and it keeps water for a moment and then goes back into the river. And then once these two first strategies are exploited, then you can drain water safely, make sure that the dikes are high enough, and if possible in a slow way. So if you can reconnect all meanders, it's better also. So now we're gonna show the two case studies, and the word to Isabelle.
So the first case study is the Gravelbeek in Heidelbeek, Belgium. The strategy is, well, there's several strategies that you're going to recognize, but space for water and renaturalization is a main issue. So the Gravelbeek is located in the Leie Basin, and it is actually the motivation why I chose the case of the Gravelbeek Basin is because of this growing focus of retaining as much upstream. So it is an upstream area and non-navigable waterway. And actually, so why do we do this? Because of this end-of-pipe solution that Christian was mentioning. In Ghent or in Bruges are no more sustainable solutions, or are not seen as sustainable solutions. So that's why we go to the most upstream hydrological zone. And it talks about the smallest river in the river catchment, which is actually the first collector of rainfall, which could be seen as the first element that could be responsible for flooding downstream. So that is why we look at those. These small rivers, they are today not really known by most of you, but the Gavelbeek Creek carries a lot of history and fame. And the most known yearly event on this water course is the Waregem Koersen. It was and still is actually one of the known obstacles on the horse race track, as you can see here in some historical pictures. And more back in history, actually, it was also the place where the Guldensporenslag took place. And today, for some of you soccer fans, it is the creek that lies next to the soccer stadium of Zulte Waregem. It runs also for more or less 8 kilometers under the E17 if you drive your car between Heidelberg and Waregem. So just to situate the creek. So there are two important water urbanism issues in the creek. The first issue has got to do with space for water. So the natural space for the water is defined actually by the topography of the landscape. And the Gavelbeek Valley, as you see, compared to the Leie Valley, is a really wide basin. And it used to be part before that, before a long time ago, I'm talking about geomorphological times. It used to be part of the Leie. After that, it was sedimented up and sanded up. So it's actually quite a flat bowl, which has a natural retention capacity. So there's small differences. So in the past, this is a map of 1770, the river used to run in a natural meandering way. As you can see here, that it was quite a green bend all the way down. And this natural water system dictated actually where the urbanization would settle. So there was an adaptation from our urbanization to the water system. They constructed their houses on higher grounds, and also the farms that were depending on water, they used to settle next to the creek and fill their ditches with water. Today there is less and less space for water, as you see here originally. So Heidelberg, Waregem, and all these settlements, they settled on the sandy platform in between the Leie and the Gavelbeek Valley. But of course there is growing urbanization, and it starts to eat away all this wetland of the Gavelbeek Valley. Also the construction of the highway, which you see here in the dotted white line. All of this, the growing urbanization that starts settling into the wetland, became possible because it was safe to live in the lower wetlands thanks to technological or technical hydraulic corrections, such as sluices on the Leie, and then on the Gavelbeek also 6 weirs, that means little dams, stuwen. And it was straightened, it was piped, even an extra exit pipe was put under Heidelbeek to drain as fast as possible all the water to prevent flooding. So the decrease of the wetlands was caused by these landfills for the infrastructure. So the E17 was heightened up. Together with that became these big plots of industrial zones that attached to it, also all landfilled. And of course also big open spaces were very attractive for new allotments. So with less space for water, the challenge is now how to deal with the effects of climate change, or better, how to mitigate, how to soften these effects. So the recently flooded areas in red are caused now, today, by obstructions and sewer overflows. And the hydraulic devices, such as the sewers and such as dams and all, have reached their limits. Sewers cannot cope with it anymore. So with increased urbanization, also the runoff will even increase, and with climate change even more. So water needs more space. So in this project, we want to the challenge or the strategy is to renaturalize. So there were 3 landscapes identified on the basis of the scheme that Christian mentioned in the beginning, to retain water as much as possible in upstream areas, then to contain for reuse also in the lower, where there's clay patches where you can store the water, and to drain, of course, as where you need water resistance, or you can maybe adapt houses to be resilient, or but you still need to drain a part. So these 3 landscapes were characterized as a part of a regional vision, and they were based on this water management principle. So the first area is the urbanized ladder edge, so between Hagelbeke and Waregem there is to densify around the Steenwegen. Here the rainwater could be collected collectively around this road and brought to the lower wetland, where you then could de-densify the area. In the second one, in the low wetlands, there you could connect the meersen or marshes again in a chain, and the runoff of these infrastructure and these industrial zones could be collected and purified in parallel basins that you see here, these lines. And the proposal here aims to integrate these water elements, infrastructure, and recreation in the kind of constructed wetland. And then the third landscape is the diffuse edge, where water is as much as possible retained upstream, infiltrated through a remeandering of the course of these tributaries of the Gavelbeek. And here actually the urbanization is more spread, and you can see how these tributaries pass through the course, where it could be again be uncovered and used in a renewed urban structure. So as a reference project to this strategy, I show Beveren, which is a project that also OSA, our research group, made for a compensation area for the extension of the port. They defined also, so according to they gave more space for water, and they defined 3 landscapes on a totally different scale, of course, as I was showing in our case study, but it's the same principle. It's about recognizing the renaturalization, the natural process of water in those areas, and defining so a saltwater area, brackish water area, and a sweetwater area. The urbanization is then restructured through densification and de-densification in relation to these 3 landscapes. And this picture shows, for example, the former agricultural fields that are given back to nature in this picture in order to give space for water, and at the same time a new program emerges, recreation or natural park. So the second issue, except for the space for water, there's a more urban issue, which is the creek village. This example is situated in Vichtes, so one of the creek villages that I mentioned earlier, where remeandering and retaining water was the case. It's located on the creek, the Kasselnijbeek, and it is particular because these villages were really settled. The origin was at a crossing street, at a street that crossed the water, so there they were located in this indigenous landscape with the castle and its moat, and then the farms that were situated next to the creek. And today this indigenous landscape has gone completely and been covered. There are several big box storage that came, so actually it transformed into a backyard. Cemeteries, parking lots, just back spaces that have been, this is for example a new development that also turn its back, and actually the creek is right below this paved area into these spaces. So what is the challenge here is with the new developments that are coming, the new urbanization, is that we can take this as an opportunity to restructure this village and to adapt the urbanization to water management instead of forgetting about it. So what I did in this project is to uncover and actually open up again, make a new civic access for this village that just had this grey road, which was a big commercial road, and so therefore serve as a parallel that could be much slower traffic, could at the same time accommodate water in the village and activate public spaces. So these two accesses could then be overlaid with a network, which could be connected with a network of slow water paths, and these slow water paths could retain rainfall inside the smaller public spaces and slow down the runoff as much as possible. So the proposal is to just add water in the village by accommodating, for example, on a public square, giving it the opportunity to swell when bigger rainfalls happen, to activate these public spaces, and I will now demonstrate with a few reference projects what I mean with that. This is in Bordeaux. This is Cœur de la Bastille. This is an eco-quartier, they call it, by Dominique Perrault. And well, they define the place by making a water garden. They define actually that this development is located inside a floodplain near the Garonne. Another example by global architects shows this the small scale elements, how they fit in, how they integrate with different scales. So here you can see how water flows, how actually the water is managed in open space, in public space. Ecological gutter in Switzerland, or a cemetery that is made permeable. Small things that make actually a big deal in water management. Or this park for temporary retention by Composante Urbaine. When this fills up, you got little islands and multiple small lakes. And floatable gardens by Agence Terre, which, by the way, is next to water management, also has a low maintenance function. So nice examples. And then Christian will tell you all about his second case in Turnhout.
Yeah, so we're going to Turnhout, which is located in the extreme north of Flanders. And there's an issue of water infiltration and retention. So Turnhout is, as I said, the north part, and more specifically it's at the what we could call the most upstream place possible in Flanders. So it's almost touching the division line between the Schelde Basin and the Maas Basin. It means that there's hardly any water in there. Although there are some issues, I will come to it later. So Turnhout is basically developed between two rivers. You can see it in this kind of perspective on the right side. So it was in the Kempen, a kind of desert-like, the right word in English, but nothing was. It's very sandy, so nothing was growing there, and so it was surrounded by kind of oasis between two rivers. And then it later urbanized with the arrival of an irrigation canal and a highway. So as I said, there are water issues in Turnhout. Actually two. One is that there are increasingly frequent floods happening downstream along the river, the A river. And the second one is within the city, that they are confronted with the almost saturation of the sewer system. And both of these issues are related to the problem or the fact that Turnhout has been urbanizing extensively, especially since the highway was there, and is about to increase even further. For the next 15 years, it will increase by 15% more. So this paving is causing runoff and more water at once in the river, as explained before. So the city took as a strategy, or had just defined the plan to split the sewer system, which is on the left side, and is now collecting as well wastewater as rainwater, to split it between sewer and rainwater. So that's what we call decoupling or half-coupling. So it means that the existing sewer network will be exclusively dedicated to sewer wastewater, and on the right side they will have to develop a new stormwater collecting system. And what interests us is, of course, not so much the sewer, but rather the new stormwater system, to measure what would be the spatial impact of it. So the first thing we do is to look at, since they will use gravity to collect this water, to look at the topography of the street system. So when you redraw every street, or at least the way a raindrop will follow to go to the river, it defines the number of streets as rivers. So it's more easy to understand if you look at the scheme on the right side. So it's the topography of the city is so that the streets, they look like a river, where you have a main one that collects all water at the lowest point, and then tributaries connected to it. So it means also that each of these sub-system has a catchment, has a paved area related to it. And so we could say, so it gives a new picture of the city. Somehow we look at the street pattern not anymore as a mobility device, but as if it was a river system. And there's also a technical issue, is that you cannot evacuate water as you want in the river. So at the bottom, the blue squares are representing the buffer capacity that is needed to buffer water coming from the city before it enters the river, because there are limits of, actually it's liters per second per hectare covered that you can not go over. And so based on this is the plan they have. We defined two strategies, because so they want to do it, but they don't really know how to implement it, or how it will look, and how it could be used as an instrument for something else. So one strategy would be how to implement spatially these buffers they need at the threshold to the river. And another strategy is looking more upstream within the city, if there are any possibilities to create extra retention and infiltration devices that could either complement the collecting system or be an alternative to it, instead of having piped system, to have something that remains above ground. So the first strategy is simply looking at where these buffers are needed and confronts it to unbuilt spaces. And what is nice about it is due to the fact that the city is surrounded by two rivers, but it's that it draws somehow a kind of green belt around the city that could become a system of park, or a system of recreational activities. So here there are some nice examples of buffers that are at the meantime parks, or kinds of things like that. And the other strategy is, as I said, to look within the city, where is there a possibility to retain water. And the name for it would be urban venon, and venon refers to what you see on the picture there. These are typically Canton features. So these are very shallow lakes that have also a varying level of water. Actually, it's in depressed areas, water gets there and gets evaporated. So it's a bit an idea of how to, it's more like a concept of how to use this principle of venon within the city. So the first thing to look at is all the potentially permeable zones within the fabric. And it could be, so that gives the map on the left side of the permeable city. And we could add to it all the post-industrial sites that can be seen as, in the short or mid-term future, as places for reconversion, where we could also implement some retention zones. And then on the bottom, more practically, look at what belongs to the city, because it would be easier to implement something on public-owned land, and look at the planned projects if there is any contradiction with what we discussed above. So this gives the picture of what we selected as potentially retention zones and infiltration zones. They need to be big enough also. Overlapping with the river as system, the streets as river system. And it helps to look to see which from all the venom, so all these empty spaces, which are the most strategically located with regard to water, which are those that could collect water because of the topography. So to make it more clear, we zoom on one of these sub-catchments, and actually there are three interesting places in that sub-catchment. These are the three blue things you see on the left side. So I will just go through it rapidly also, but it shows how here in that case it's the front yard of a school that is now a kind of mix of parking and playground, but it's really at the meeting of two collecting streets, so this could become something at the meantime public space, a qualitative public space, and at the meantime collect water and let it infiltrate. These are just images of what a small-scale retention facility could look like. Another place is the parking in front of the famous museum of the playing card. That is very informal, and here also it's at the confluence of streets as rivers. And here, as a reference, I showed to the people from the city, it's a parking made by Agence Terre in Marseille, or nearby Marseille, where the parking place is structured by a number of swales that collect water. So in the meantime, it has some landscape quality and very hydraulic function. And the last one here is a playground in the southern part, where also there are examples that were made before. And the reaction of the people of the city when I showed that, actually when I showed this, they were afraid of security and how to make it, how to keep the place clean. If you accumulate water, will get mud, etc. So these were examples of to make suspended platforms above very permeable surfaces. So it's not really a problem if the grass gets a bit dirty. So it's just this distinction of surfaces that could be an answer. And then another issue for this project is how to keep water at the level of the street. I will not go too much in detail also, but it shows some possibilities. So as a conclusion for this case, our goal is not what I've shown here is a number of places that could look nicer. Of course, it's not our goal as urban designer. It's more to see how the sum of all these small interventions could become a network, could be part of a system within the city. So, for instance, a system of open spaces or parks, and then later this system of open spaces could also determine maybe further densification. And another remark, the first one is striking. The first remark is to see how striking it is that a city that has very little water will be affected by the new water management approach, where you are obliged to retain and to store water. So this shows how important the spatial impact will be. I will rapidly, because I'm a bit frustrated when I show this, because it's work in progress, and We didn't go much further than this. So I will just show another example where it has something to do, but not really. Where it's also a problem, an issue of water retention, and in what way could it be used for urban restructuring. And it's focusing on the region of Le Centre in Wallonie, which is known for its mining past. So in red you see all the terrils, which are the subsisting hills of waste material that they excavated. And the region is actually confronted with problems of subsidence. Subsidence, it means that due to mining activity, you had some underground collapses, and the surface on the ground got lower, and in some cases the river was hanging over plains it was crossing. So there was a big risk of floods, because if the river ever overflows, it gets into these depressed areas. So in reaction to that, in the 60s, they made a big plan of canalization of the whole river system. And you can see what it looks like in the bottom. So it's been working well since then, but of course, from the ecological point of view, you can guess it's not the best solution. So we worked last year with students from Oslo, looking for an alternative to water control. Instead of canalizing everything, is there any possibility to retain water so that we prevent peak flows, and we downstream we could maybe reopen this concrete-like valley to something more naturalized. So if we zoom on that part and look at is there any possibility to create some retention basins? Well, there are some in red, and what's interesting is that it's in some cases meets some of these terrils, some of these old industrial areas. And so we made the exercise with the students, and they focused on Anderlu, which is one of these villages that was initially structured along a river, and then with industrialization got further developed, but especially there was, if you see the section there above, there was a terril that was put in the middle of the valley. So now the village is really surrounding a huge terril in the middle of the valley, and the activity has completely ceased. So the question is what to do with this abandoned terril, with this village which has no real future until now. And when you look at just above, a bit south of the terril, you have also this confluence of many rivers, and there are some retention facilities, but very technical. And so the proposal the students made was it was a bit radical, but to inundate the whole plain using the terril as a kind of barrier, as a kind of dam. And so this terril, which was the center at the moment, didn't work anymore, could become again the central core of the village. And they made an extrapolation of how this new waterfront could become the place for new developments. And they made a reference to Tantana here, where the terril becomes actually a black island, and it's in a way it emphasizes the artificiality, which makes it beautiful. So this go to the conclusion.
So we've come to the end of our presentation, and I would like to summarize what we've been showing you. So of course, each chapter was only a small abstraction of what the complicated interdisciplinary work between what we've been conducting between the hydraulic engineers and us as urbanists. And in the challenges chapter, we've talked about climate change, flooding, climate change scenarios. It's all very technical, but I want to assure you that we're not trying to become hydrologists. We are interpreting the hydrological engineers in our urbanism language, and we hope that this conversation also works vice versa. So this interaction moves actually both disciplines to a new approach. It goes from managing the water from a monofunctional, hard engineered field, as you see on the left, towards a multifunctional, integrated engineered field, so constructed wetlands, that kind of thing. Like here, this example, maybe you recognize the shape, this is the Gavers in the Gaverbeek Valley, which is actually a drinking water filter, but at the same time, provincial domain, recreation happens there, and it keeps the space open in a very densely populated area. So it has an urban structure, but it has also multiple functions. So to conclude our, here it is. To conclude, our major concern is that water management is combined with other spatial claims. And I've summed up here some of the recurring strategies that we've been using in the cases, which is, well, space for water in the first case, but also retention and urban structuring. Renaturalization comes back actually in all of them, and de-densification as well. Densification on one side, de-densification. So those strategies are more or less important in coming back. So this actually brings us to our starting point and our title, in which we put water as a structuring element in urbanized Flemish landscapes, as well in urban areas as in open spaces. I also would like to mention that what we do is part of a bigger research group that we're conducting at the OSA research group. And for example, we have some cases in Vietnam. Tuan is working on Hanoi. Annelies will be working for Belspol on also Vietnamese cities. There also our postgraduate center is conducting some studios that have been working on Kanto this semester and Erie Canal. And actually all of this this work sometimes gets published, and that has happened 2 years ago when the conference on water and urban development paradigms took place. But also this water urbanism book that we've got here for you. And it's for sale, so if you'd like to have a look, then you can also get it. So thank you for your attention, and we leave the floor open for questions, and of course you can still reach us afterwards if you're too shy. Any questions?
Est-ce qu'il y a des questions?
I can't see you, so you gotta speak up if you have one.
Thank you. I'm Ulrich Schollart. I work here in Brussels with the administration. My question is, the examples you've given us are, of course, in smaller cities. We are working in densely populated urban areas, larger cities. Do you know of examples that you could mention where water management was done on a large scale in large cities, the size of Brussels or larger?
Well, yeah, there's different examples, of course, because it's basically, I mean, in the Netherlands, there are a lot of examples that we could give you, but they deal with a totally different problem. They're having the subsidence and the dikes that need to go higher, and their water system is actually much more complicated than ours. And in Belgium, also in other cities, a lot of historical work with restoring water management systems to use them in urban space, but also for water management purposes. In Mechelen, for example, this is a very good example of in a European project together with some Dutch cities, but also in England. So it's a European network of water cities. But a particular example that is interesting to look at, well, we've been looking at indeed upstream areas where the big cities don't really occur until now.
We can look for it and if you take contact with us.
Yeah. Because we've got a whole bibliography that could directly guide you to what you're looking for. But at this point, I can't help you further.